So let me go through the energies of this diagram. If you were unsuccessful, if you got all those right, you can skip this, no problem. And so let's fill in the potential energies here. So when we get to the bottom of the hill, potential energy would just be zero. And I'm not going to put joules in here just to kind of save time here. Now, what will the potential energy be at halfway? So if you realize that this is the 8-meter mark and this is the 4-meter mark, there really wasn't any math needed in these, although you could have used math if you wanted to, but I didn't think you needed to. So what would the potential energy here? Well, it's half of 220, so hopefully you see that that'd be 110. Now, let me then fill in. I think next I did one of this potential energy that we would have here. What would it be at the 6-meter mark? Well, here what I actually did to myself is I said, well, if it's 220 at the top and at the halfway mark it's 110, then what I actually figured out is the distance between here is 110. So this is halfway. So it's going to be halfway between here. Now, if you actually find the difference here, 110, divide 110 in half. So that's really what we're doing here. We're figuring what's the halfway mark? And halfway is 55. So it's 55 more than 110, which is 165. So this would be 165. I hope that was the answer that I put there, or I'll go back and make sure of that. And so hopefully that kind of makes sense how that would work, because this is the halfway mark. Again, this is just kind of conceptually with some numbers here. And then over here at the 2-meter mark, since this is, if we figured the ball would, if it was over here, it's that 55 again. So if we cut 110 in half, we would actually found it's 55 right here. So the energy would be 55 right here at this point E as well. I'm not sure I asked you that one, but now what would it be over here at F? Potential energy would be 165 again. I know I didn't ask you that one, but just reviewing that. And then up here again, it'd be back to the 220. So now when you do the kinetic energies, it's going to be the difference of 220. That was the total energy of the system minus the potential. So here we'd find this is going to be 55. It would be 110 here. At the very bottom, then it's all converted, so 220, and that's pretty wonky. What would it be here? Well, 55, and actually come over here. Actually, I know 165 is that would add up to the 220. Here we would have 55 again, because it's the same as we have straight across from it. And then my potential energy up here would be 0. So hopefully that helps understand that question, or at least how I came up with those on that set. So, all right, thanks for watching.